Okay, there's a lot of vocab in this lesson, so keep your thinking cap on and be listening carefully for those jargon terms, those terms that are specific to this topic, okay? So this topic is going to be the positive feedback loop in anthropogenic climate change. Now, there's one of our words. So let me talk about what that word means off the top. Anthropogenic. Anthro meaning like mankind, genesis meaning origin. So what anthropogenic means is man-made, okay? So we're talking about the positive feedback loop in the instance of anthropogenic climate change. Now let's talk about a positive feedback loop. A negative feedback loop is where there's a stimulus and a negative response. So like the air conditioning in your house, the thermostat, and it regulates the temperature in your house or apartment or wherever. If it gets too hot, the AC kicks on and brings the temperature back down. And then when it's down enough, it stops. And as the house heats back up, then the AC kicks back on and turns it down again. That would be a negative feedback loop. Conversely, as you might imagine, a positive feedback loop is where a stimulus increases its own stimulus, okay? Where something gets too high and then it snowballs and gets worse because of that stimulus. So that's what's going to be happening here. So let's talk about the original stimulus of all this. There is natural climate change. Say that again. There is natural climate change. That happens. That's why none of you had to fight a saber-toothed tiger on your way to school this morning. Species come and go. They become extinct and then evolve and things like that based on global climate changes. And we know from myriad of resources that natural climate change has happened and is happening. It is a natural process on the earth. Now, in addition, that's an addition symbol that's circled. You got to remember this. It's not one or the other, okay? All of this is happening. All of this is connecting and all happening at the same time. In addition to natural climate changes that do happen, then there is also CO2 being added to the atmospheric circulation by the burning of fossil fuels in the last 150 years or so. Now, let me explain what I mean by added to atmospheric circulation. It's a closed system. The Earth is a closed system. So this is not new carbon. This is carbon that was stored in carbon reservoirs or carbon sinks around the globe. Some of it was deep underground in fossil fuels. Some of it is in soils. A lot of it is in organic matter in the bottom of swamps and stored in permafrost. Permafrost is frozen soil that is, those organic compounds are prevented from decomposing because the soil is frozen. So the rate of decomposition is incredibly slow. In the bottom of swamps, cold swamps and things like that, of course, decomposition is a certain rate, and as if it warms up, the rate of bacterial decomposition also goes up. And those carbon compounds that were deep underground in coal, oil, and natural gas have been locked underground for millions and millions and millions of years and not in the atmosphere in the form of CO2 circulating throughout the climate or through the atmosphere causing climate changes. Okay, so we're talking about CO2 that has been added to atmospheric circulation within the last 150 years from the burning of fossil fuels. Let's clear all that up. Now, natural warming plus anthropogenic sources of CO2 lead to increased warming. And we are drawing sort of a loop here. So you got increased warming. Now with increased warming, a lot of our permafrost is melting. Soils are getting warmer. Swamps are getting warmer. Deep ocean sediments are getting warmer. And so bacterial decomposition increases. So we've got an increased decomposition of organic matter from permafrost soils and swamps. And that's going to lead to an increase of two very important molecules here. And this is the reason I've got them circled in yellow. Carbon dioxide and CH4, methane, or as methane as the English say it. Now, methane is important here because it is an extremely potent greenhouse gas. In fact, it's many times more potent in terms of the warming effect that it has than CO2 is. So we're getting a global increase of both of those from a global increase of decomposition, from a global increase in warmth. Just so we're keeping track of it all. So we get an increase of those from increased decomposition and melting permafrost. So we've got increased warming. And then with increased warming, of course, we've got increased evaporation. And so now we have an increase in H2O sub G, water vapor, in the atmosphere from evaporation rates increasing as temperature increases. So one of the things that we know is that water vapor itself is a greenhouse gas, and there's more of it in global atmospheric circulation because of global warming. Warmth goes up, evaporation goes up, water in the atmosphere goes up instead of being on Earth in a liquid state or in a frozen state. So I've got increased CO2, increased CH4, increased H2O sub G, and now I've got a more increased warming because those are greenhouse gases. Those are leading to more warming, which is what I've got written right here. And now, because I've got an increase of warmth and increase of water, and globally the climate is increasing in its heat holding capacity and warming, then I have an even greater increase in the rate of decomposition, and therefore an even greater increase in CO2, methane, and water vapor, and the cycle continues. And it spirals out of control like a snowball. That's the positive feedback loop in anthropogenic climate change. I'd be remiss if I didn't acknowledge an issue right here. Over the last few years, 30 years or so, then this issue right here has been polarized, spun, oversimplified by the political machine here in the United States. And what has happened is that two major things is that one group of people will only acknowledge natural climate change, and another group of people will only acknowledge CO2 added to the atmospheric circulation from burning of fossil fuels. And then things got boiled down even more to where now it's a function of belief. Do I believe in climate change? Do I believe in natural climate change? Do I believe in anthropogenic climate change? Do I believe the CO2 is changing anything at all? It's not a function of belief. We're not talking about Santa Claus and Chupacabra here. The question is, what data are you willing to read and acknowledge as being data? That's what it comes down to. What data are you willing to look at and acknowledge as being there, existing? And conversely, what are you willing to deny completely? Okay? And this is where I'm not going to tell you what I think on this issue. I'm going to tell you what's on the test. This is the position of the AP exam. Okay? But I will tell you personally, do not boil down science to belief, and do not reject data because it does not fit your political agenda that you have subscribed to for the last 10, 15, 20, 30 years. Look at data, listen to what's being said, and then ask yourself whether you're willing to acknowledge that data or not and update what you think.